All right, good morning. So you don't get to go play with Legos today. You have to sit in here with me. I'm sorry. So today we're going to talk about A3s. How many people have ever done an A3? So we have one. Okay, good. And Ali is handing out some papers that today, instead of a test at the end, you're going to do an A3. So in groups of 3, you're going to have a little problem we're going to work right at the end, and you're going to work through the sections of the A3 and figure out something neat, and we'll get there in a little bit. So don't everybody try to get a piece of paper themselves, just in groups of 3, 2, 3, whatever it works out to be on your row. So this is the first time I've had a chance to talk to you, other than when Tom asked me questions over on the side. I thought I'd give you a little understanding of who I am. Greg Harris, got my bachelor's degree in industrial engineering here a long, long time ago. Went to work out in industry at Texas Instruments after I left here, and worked for them for 8 years. Then I made supercomputers for a little while, and then I moved back to Alabama and worked for the Federal Reserve Bank, designing new processes for cash and money, which money really does not smell sweet, by the way, but it stinks pretty much in the vault. Then I went to Huntsville in 1990 and started making cruise missiles. And after cruise missiles, I ran a sewing operation as a plant manager. And then after a sewing operation, I went to the metal stamping company and as a production manager and director of operations for about 8 years, doing automotive supplier to Mercedes and Chrysler. So when Tom was over at Chrysler making parts, I was sending junk to it. Yeah, at least that's what they kept telling us all the time, as we were sending junk. So I've spent a lot of time manufacturing things, making things. And then while I was at the metal stamping company in Huntsville, a friend of mine at the University of Alabama in Huntsville came to me and said, hey, we're starting this thing up in Alabama called the Alabama Technology Network. It's a manufacturing extension partnership. Why don't you come over to the university and run the center for me there? So I did that for 12 years, got my PhD in industrial systems while I was there. And then for the last 5 years, I worked for the U.S. Army out at Redstone, but I was actually running a program for all of government called the Digital Manufacturing Design and Innovation Institute in Chicago. And it was one of the advanced manufacturing initiatives from the Obama administration. There's 10 of them out there now from the Department of Energy and Department of Commerce and Department of Defense. I was doing one of the Department of Defense ones. And in doing that, I got to come down and talk to Chris Roberts and the dean and tell him what we were doing about in the National Network for Manufacturing Innovation and DMDII, and that led to one thing led to another. Now I'm here. So that's a quick my career. Now, why are we talking about A3s? I mean, Toyota does all this great stuff, right? That's what Tom and Dr. Black's been telling us, right? That they figured out all of these great things. Why don't we just copy what they do? Why do the copies of tools that Toyota uses? Why hasn't that created a bunch of other American Toyotas? Does anybody know of an American Toyota example that has been as successful? Now, what do we mean by Toyota being successful? How do you judge success of a company?
Cost, high profit, or high revenue.
Okay, so profit, right? Every company is judged by profit. Shareholders want profit. They don't want low cost and low revenue. They want profit. Profit is shared. If you're not in business to make a profit, you're a nonprofit organization, or you're out of business. That's the way it works. That's the way all the companies I've been involved with worked. If you were out in business, you were trying to make money, and you're trying to make money and make it at a profit, because that's the only way you can exist. Now, what has Toyota done that a lot of other companies haven't been able to do? What have they been consistent at? Quality. There's a lot of companies that have pretty good quality records, but that's a good answer. What else? They grow. Okay, so they've become one of the largest, if not the largest, car company in the world right now. But even size doesn't guarantee that you're going to be really good at it. They've consistently made a profit. They have consistently, over the years, regardless of what the economy is, made a profit. Now, why is that? What are we learning in here?
The system.
The system that they use. And what is the system that they use? Toyota production system. The Toyota production system is made up of what? A bunch of stuff that you're supposedly learning in here, right? So we've learned a couple of things that they do, but what has been an example that's been presented so far to you is that they do a really good job at continuously improving, right? They consistently do that. And the way they do that is create this learning environment and create this opportunity for continuously improving and changing their processes. But they don't just change. What do they do? I love the example that Tom gave was with pushing the rock up the hill, right? They standardize, right? So how do you have to have some system in place to allow you to do that, right? There has to be some way in which you can consistently talk about all of these if everybody's supposed to be doing continuous improvement, and all of these groups are continuously changing the process and re-standardizing, there has to be some way to manage that. And that's what they do with A3s. The A3 is their reporting system. So continuous improvement requires that you figure out a way to actually do problem solving. So they'll tell you that they teach problem solving to the employees at Toyota. That's what they do. They don't teach SMED, they don't teach quality, they teach how to solve problems. And there's a lot of tools that you can use out there. They didn't create a whole bunch of new tools. They took tools that were out there and been used by industrial engineers forever and figured out how to employ them within their operations. So if in most of these, most other organizations, most other companies, they really don't address their problems that they have every day at the root level. What they end up doing is continuously re-solving these same problems that they have day to day and year to year. And what they end up really doing is developing some really good firefighting skills. And then that's how people get advanced within their career, right? I solved that problem, so I get to be the next boss, right? And guess what you do when you're the boss and your reputation is based upon firefighting. What happens, Tom?
You firefight.
You firefight more, right? Because that's what got you to your next position.
And you hire firefighters.
And you hire those that they can do that for you. And all of a sudden you got all these firefighters out there that are doing things, but guess what? Nothing's being standardized. Nothing's being done. So you end up fighting those same fires year after year after year. So A3 is the tool that Toyota uses to standardize their problem solving and reporting of this and using it throughout their management system, all the way up from the first engineer on the floor all the way up to the boardroom. They use A3s to talk about the problems that they're having. And what they call it is A3 thinking. And it's really about creating good problem solvers. Okay? Because they say if we can create good problem solvers, we'll have this thing that we'll continuously improve and we'll continuously make a profit. So they believe that this is their competitive advantage. Not their designs of their products. Their competitive advantage is in how their people solve problems. And they continuously do that. Both of the pillars that we've talked about in here are based on problem solving. Okay? The process is really, your processes are made stronger by surfacing the problems at the root cause, but guess what? It's really hard to think that deep. It's hard to think beyond the surface. So how many people have tried to describe a problem to somebody and the person you're talking to catches like the first little piece of what you're saying and says, well, this is what we'll go do, and we'll fix it. You're going, but wait, there's more to it than that. No, we're going to go do this, right? So it's really difficult to get that level of problem solving that digs down into the root cause of this, and it's really even harder to make the changes to check that changes are actually working. So what's the method of problem solving that Toyota uses? Huh? Well, that's a problem solving tool, but what's the methodology that they adopted from Deming and others? This should be on the test, I think. PDCA, right? Plan, do, check, act. Isn't that what we've been talking about in here for the last couple of weeks? PDCA process. Plan, do, check, act. That's what Deming was espousing. That's what Taiichi Ono said. This is the way we're going to go solve problems. So plan, do, check, act. What's the first part? Planning is what? You can also DMAIC is another approach to it, but they're very similar. Plan is understanding what the problem is, figuring it out, putting together how we're going to go solve that. Do is what?
Fix it.
Implementation, right? What does check mean?
Make sure it's fixed.
Make sure it's fixed. Go back and look at it and make sure we've achieved what we expected to achieve. What is act? Follow through and standardize, right? Mm-hmm. And then look for the next ways to go improve.
And I would consider check, not check to make sure it's okay. I would consider it, how can we improve this?
Well, yeah.
Because you may have implemented it properly, it may have done exactly what you want, but you want to be better every day. So you're looking at it and reevaluating the possibilities.
Right. So but most companies that I've been around, they'll talk about PDCA, but what they actually are is plan, do, plan, do, plan, do, plan, do. Because what are we, engineers, right? Is everybody in here an engineer? Wants to be an engineer? Nobody wants to be an engineer in here?
I didn't want to be, I'm not one.
Well, I know you, but you're special. Okay. What do engineers do? Solve problems, right? Now, engineers solve problems. So where's the fun in engineering? Getting in and solving the problems. So is it fun to go back and check what you did and understand, did I accomplish what I need to accomplish? Is there more to accomplish? You go back and review what you just did or move to the next problem? You want to move to the next challenge, right? So plan, do, plan, do, plan, do, and we end up spinning in that cycle. So check and act are critical to making sure that what we implemented is in fact doing what we wanted it to do. Are there better ways to go and do this? Yes?
Sorry, this may be kind of dumb. Can you elaborate on the difference between do and act? Especially act, I'm not really clear on what that means.
Well, act is the follow-up. Is there something more that we need to go do?
It's the improvement of the improvement.
Yeah. So
we've implemented something we know without question there's a better way. Even after we've done it successfully the way we planned, there's still a better way because we're always evolving quality, we're always evolving throughput, we're continuously improving. So we have to look at this continuously to see other opportunities. And when we see a better way to do it, because one of the employees that are affected by this may say, hey, if you'd have done this, that would have helped. And you go, and then you implement another improvement to it. So you're always evaluating, like rolling the ball up the hill and standardizing. You're always trying to roll the ball up the hill. So you have to do check. Check is to evaluate whether we can make another turn and re-standardize. It's philosophical.
Right. It's actually what they'll say is you need to step back and review and understand what happened. That's what ACT means. And by doing that, you determine there's additional opportunity out there.
That's a good question.
It's
though,
all
by the
it's
way.
all
It's
it's
not-
all
it's not
incremental,
that
right?
clear.
It's incremental improvement. That's what we don't go fix things once and we're done. It's continuously looking at where are the problems. And every time you push that ball up the hill, you uncover additional problems. And you need to make sure that you're figuring out ways to go fix those.
So if you can imagine in a global automotive world, everybody's trying to beat the other and it's hyper competitive. If you just get cast in stone, it's just a matter of time before you're in serious trouble. So you have to keep reevaluating.
So because of Toyota's approach to this, they believe that their competitors can copy all the tools that they have. They can copy everything that they do, but they'll never actually catch up with them because they're always ahead. So you can actually go in and Toyota will show you almost everything in their plant. GM and Ford continuously go through Toyota plants and observe what they're doing. But by the time those companies catch up with where they are, Toyota's going to be 2 more steps down the road. So this is their approach. So this PDCA drives this culture in Toyota, and the A3 is the way that they report these efforts, the things they're doing. Yes.
Can I add something to this?
Sure.
So my understanding is that when you're defining metrics, we do a plan to check act, and then when we are monitoring the metrics, that becomes a check, and the cycle starts like we call it cap 2, check, act, plan, and do. And it's PDCA for the first time, and then it's cap 2 afterwards. This is one way of thinking.
And that's the way to continuously monitor what you're doing, right? To understand if you're sliding back or you're holding what you expect. So that's a way of looking at the standard.
And if you have your Pareto and here are your bars and you've improved everything, are you going to quit evaluating your Pareto even though the bars aren't as tall? No, you're going to keep going after the problems. And they're going to be the same solutions you had before that you're trying to fix. It's just that philosophical approach.
So this A3 is their way of thinking at Toyota. It really provides them a disciplined way of reporting. So if you're an engineer and you're walking in, the manager's walking down through the plant, and you better have a problem that you're working on first of all, because that's what they expect, right? That's their culture of solving problems. So if you have that in your portfolio, the manager walks up, you have to be able to take this A3, set it down, and explain to him in the 3 or 4 minutes that you have right there with him of what you can do. So of what you're working on these problems. So it's not just a report writing; it's a disciplined way of reporting the problems, because the manager knows that regardless of what engineer he goes up to, or what supervisor he goes up to, that A3 report is going to be in a standard format. He'll be able to see what the problem is, understand what the problem is, look at what they're doing for countermeasures, and what their plan is for implementation. And because it's a standardized report, it doesn't matter what the topic is. He can understand where they are in the process. So that's why they use this. But just because you have an A3 form out there doesn't mean that you're solving the problem correctly, right? So you have to be able to, just because you document it on an A3 doesn't mean that you have the right answer. So it's always under evaluation. It's always under review for input. And the reason that they can do that on a consistent basis with all of these issues that are going on within their company is because they have this disciplined way of reporting their problem-solving capabilities. So an A3 report really forces their culture in a way that allows you to create a learning organization. So first off, it forces you into a logical thinking process. You have to be able to work your way through a problem in a structured manner. Okay? It keeps you from jumping steps. It creates objectivity. It creates objectivity because when you go through these steps to evaluate the process, you are forced to understand what the root cause is. And if you don't get to the root cause, when you go to review this with your manager, your supervisor, when they tell you to bring your A3 and show them what they're doing, that's what you will be evaluated on whether or not you've answered the root cause question. Okay? Results and process. Results and process are equally weighted within Toyota. You make in U.S. companies, results are rewarded pretty much. It doesn't really matter how you got there. It's the results. That's typically been the way of U.S. corporations, U.S. organizations to reward. At Toyota, you may get the right answer, but if you didn't use the right process, or you didn't document the process, you won't get quite the reward that you got. You're going to have to go back and figure it out. So equal weight on how you solve the problem in addition to the answer that you got in solving the problem. Synthesis, distillation, visualization. The ability to synthesize a problem down to something that you can draw on a piece of paper and explain lets them understand that you know what the problem is. Einstein was quoted as saying, if you can't explain a problem simply, you don't understand it well enough. Okay? That's what they're approaching here. If you don't understand this enough that you can sketch what the problem is quickly for your manager, then you don't understand it enough. The solution to the problem has to align with the corporate goals in the A3, and they want you to show where that alignment happens within it. Coherence within and consistency across. So coherence within means that there's a logical understanding of the problem, and it works within that entire unit, whatever that unit may be that you're looking at. If it's a cell on the floor, that the answer to this problem over here is not inconsistent with those, or not incoherent with the other parts of the cell. In other words, you haven't created a problem in the cell because you've solved a problem over here. It has to be coherent through that, and it has to be consistent across other cells that do similar things across the corporation. They use these A3s to actually understand how to solve a problem in your organization, but what other organizations might this same solution work. And then systems viewpoint. Obviously, they want you to step back and have we improved the overall system by the problem solving that we've just done? If you haven't improved the overall system, then we need to go back and look. Maybe we haven't really solved the right problem. Okay? So A3, how did it get this name? Does anybody know?
Paper size.
Paper, size of a paper. Do we have A3 paper in the U.S.? No, we have 11 by 17s. It's close. It's not quite the same.
Say 3.9 you have.
What?
A3.9.
A3.
It'll work for our purposes.
So in the A3 report, we're using a concise way to express information. So it's interesting, they're actually pushing at Toyota now to go from an A3 size down to what's the letter size for them? A1, A2? A4, A4. So they're trying to push it down to that so that you can get even more concise with it. So continuously improving their reporting methodology also. But that's, I mean, an A3 report is difficult to start using, but once you've started using it, you sort of understand it. So it's the typical standard format for problem solving. There's multiple ways to use the A3. You can use it for problem solving. You can use it for proposals. You can use it for just reporting. There's different ways of using that. We're going to talk about the problem solving one mostly here. And there's typical sections: the theme, background, what the current condition is, what is the goal you're trying to achieve, what's the root cause analysis, what countermeasures can we come up with to solve the problem, how do we confirm that we did that, and what are the follow-up actions that need to take place. But what's important really isn't the format that you use. It's more about the way of thinking. That's the way you think through the problem. So it lays out the plan on one sheet of paper. It has to be visual and extremely concise. Why do they want it visual?
So everybody will be on the same page.
So how long does it take? Oh, that's a good answer. But how long does it take to read a problem statement and read the answers in written form? Some people read fast, some people read slow, and some people comprehend, some people don't comprehend. But what about a picture? It's pretty easy to tell, right? And if I'm only using one page to do this, and I need to write lots of words to describe it, or I can use a picture. You know that old thing, a picture is worth 1,000 words. It's actually true. Okay? So they want to use visual. It tells a story. It's laid out from the left-hand upper side down to the right-hand lower side. This is the way you read it. It allows us to understand the process, reach consensus. Why do they talk about consensus?
If it's going to be standardized, it has to be sort of agreed upon.
You have to agree to it, right? And the only way to come to that agreement is to come to consensus. What does consensus mean? What's doesn't have to be. That's what we all hope it is, right? It hopes that we're all in agreement. But consensus doesn't mean that I necessarily agree, but I accept what the answer is, and I'm willing to go forward with that. I may have a different opinion of what the answer should have been, but I understand what you've said, and I understand what your approach is, and I'm willing to go forward with that with my full effort. Okay? That doesn't mean that I agree with it, and we don't all have to agree, and you're not going to agree when you're out in industry.
It also means you take due care in trying to make sure that everybody's satisfied and do agree, because they may have a perspective that needs to be incorporated in the solution. So you must work to try to get agreement. And at a minimum, you have consensus where everybody goes along with it.
Right. It connects the problem with the solution and persuades others of what the solution should be. So this needs to be a tool that you can use to express what you think the problem is, express what you think the solution is, and how we're going to go do that so that you can get that consensus. It allows you to have dialogue within the organization. So by surfacing these at the root cause level, you're able to go and start politicking is a terrible word to use these days, but it's a way to go out and start talking with others and helping them to come to the understanding of what the problem is and the solution that you want to go do. So it encourages involvement in the problem solving. And the reason that one of the reasons they really like using the A3 and these standard formats is it really forces the 5S of information. What is 5S about?
We haven't talked about that yet.
Okay, but you have a team that's doing it, right?
Yes.
So 5S is a way of cleaning and organizing and managing the way we go about doing our jobs and the work that we're doing. Same thing happens here. We're able to organize our thinking and our problem solving. So all the projects, whether they're big or small, use these A3s. And when you're creating an A3, what you're trying to do is tell the story of what the problem is and what the solution is. Now, this doesn't sound like engineering at all, does it? How many people feel uncomfortable right now? Do we have any storytellers in here? I know Dr. Black is. So how many people do you like telling stories? Y'all got to wake up here. I need some feedback. Come on. Yeah?
Yes.
Okay. So being able to tell the story explains what the problem, and you can explain what the problem is. So you want to know whether you're doing a proposal or whether you're trying to make an improvement or you're trying to solve a problem, what is the story that goes along with this? Because that gives not only what the issues are, but what the context is, so that you understand why the solution is what we want it to be. It's 4 to 7 boxes based on the type of where you are in the problem-solving process right now. Each box contains visuals and graphs and sketches. You only use words when you just absolutely have no other way to communicate what it is that you're trying to do. So this is an example of a A3 approach. John Shook, who wrote the book Learning to See, who's going to be here in October to talk with us, developed this template. It's not the only template to be used. There's other templates that can be used, but this is a general one that can be used. We're going to go through each of the areas. But you have a background, you got the situation, what the goal is, how are we analyzing it, what are we recommending, what's the plan to do, and how we're going to follow up with it. So if you can see, if I could fill all that out on the problem that I'm working on, that's a pretty fast way of explaining what things are going on in the issue that we're trying to overcome. So let's talk about each of the pieces. Up at the top, there's a theme up here, and it's really asking, what are you actually talking about? It describes it describes what the problem is. It's typically one statement, and you want that one statement to be very descriptive of what you're trying to accomplish. You need to be objective when you describe it, and it should focus on observed problems, not advocating any particular solution. So you don't want to say implementation of a single-minute exchange of die at press 3. That may not be what the problem is at press 3. Let's describe what the problem is at press 3. It could be too much downtime at press 3. It could be that it's a total productive maintenance issue. It could be an OEE issue. It could be the changeover issue. It could be a lot of those things, right? In the background section, we're going to talk about document any kind of information that's essential to understanding what the problem is there and how we're trying to solve that problem, or what the problem is we're trying to solve. We want to communicate the background. We try to do it visually, so you want to be able to use some kind of graph or chart or flow diagram or something to explain what's actually going on here. Because somebody's going to walk up, say the vice president's walking the floor, he comes up to your area and says, okay, show me what problem you're working on, what's your A3, and you pull it out. Well, it may be a problem. It may be a process that he's not actually familiar with. But if you have the process graphically described in that section in the background, now you can go through and explain to him really quickly what it is you're trying to solve, what the problem is, and they can grasp it. You want to make the context of the situation as clear and visual as possible. You want to identify the target audience. Okay, am I doing the A3 for my supervisor? Or am I doing this A3 for the board of directors? There's two different approaches I want to use there, right? You want to provide what information the audience needs to know before they can go forward. So you need to present all of the information that's required before you get into understanding what the solutions might be. How does this topic align with our company goals? Toyota looks at it and says it's all about production. How do we standardize and optimize our production process? So if there's a problem out there and you can reduce time out of the process, Toyota doesn't say, oh, well, let's go figure out if that's the right thing to go do. They say it's all about the time in the process, but that's an automatic. If this does that, then that's what we're going to go do. You need to include any kind of historical information, dates, names, or anything else that might help explain what the problem is. The current condition is the most important section of the A3. What is it that we're dealing with? What are the problems? You try to make it very simple for the reader, again using visuals by charts and graphs and tables. The data should always be actual data, not just something that you guessed about. You need to be able to show this data came from that piece of equipment, or this came from that cell. And these were the days we took that data over it. And what we want to do is look at the overview of the current state of the process, highlight the key factors in there, and identify the real problem in the current state, you being quantitative in the way we approach it. For goal statement on our problem-solving A3s, it needs to look at least two things. One, how will we know that the project is successful at the end of the implementation? And two, what is the standard or basis of comparison that we used? How are we measuring it, and what are we comparing it to? Those are the things we want to look at as a goal. So the goal may be we need to take 2 seconds out of this cycle time, out of this piece of equipment to meet our TAC, right? So why are we doing that? The goal we align with is to meet TAC, right? We want to make sure that we're always meeting our customer demand. So clear goals, clear measure of performance. How are you going to collect the data? Root cause analysis. So failing to address any kind of root cause means that the problem is probably going to happen again, right? If you don't fix the problem's going to show back up. So there's a lot of tools that we can use in root cause. One was the 5 whys. Somebody here said using the 5 whys. Has anybody used the 5 why approach before? Got a couple. So what does 5 why mean?
You ask why 5 times and eventually you'll get through to the problem.
Okay, why?
Because it keeps every why gets to a deeper step of the process. So say a part keeps having this defect. Yes, why is it having this defect? Well, this machine's having this problem. Why is the machine having this problem? Eventually you have enough time to get through to the problem. Right.
Good answer. So if you ask why is something happening, the first thing you're going to get is the obvious answer, right? Okay. But is that obvious answer the real problem? So you continually ask why and dig deeper and deeper, peel that onion back more and more. And if you ask 5 times, you'll finally get down to what the real problem is. Experimentation, design of experiments. There's a lot of different ways we can go do that. Ishikawa diagram. Anybody know what an Ishikawa diagram is? Fishbone diagram. And what does that mean?
Basically, you have 4 measures to measure: man, method, measurement, materials, and those are like the big goals. And then you have to.
You list out on each of those branches. You come off and say, here's a problem that could be. Here's a problem. So it's a way of us going through and analyzing what the problem is. Pareto analysis. Most people understand what Pareto analysis is. You want to attack the one that's causing you the biggest problem right now. The 80-20 rule. There's a lot of other ways of doing root cause, but the goal of doing this root cause analysis is to make sure that we are understanding cause and effect. Because if we don't understand cause and effect, we're just guessing at what the answer might be. Okay. So you want to show what the root cause is. Y'all can read the key points on there. I want to get down to what the fun stuff today. So countermeasures address the root causes using lean design principles. We've talked about lean design principles in here, focusing on what the corporate goals are. How we're, the goal of Toyota in their production operations is to optimize production, right? Minimize all of the waste in that system and allow us to produce at the most efficient way possible, because that's where we make profit, right? The goal is to move the organization closer to the ideal state. We're going to talk about current state, future state, and what that might mean. It's a action list of the problems that we're going to, the problem to how it's going to be addressed. It's important to know what did not work as much as it is important to know what did work when we go do this. So the things that didn't happen, right? We learned from that, right? You learned that, okay, that didn't solve the problem, but we made a little bit of progress on it. So we want to make sure, though, that we're addressing what those root cause problems are. The check or confirmation of effect, or the plan section of this, is a list of activities for implementation and who's going to be responsible for what and when. So this is your project management tool section, right? Where you're saying, here's what we're going to do, who's going to do it, this is the team, this is when they're expected to have it completed by. Okay? So this is how we manage our project. It should also, though, be establishing that causal link between the action items that we had and what we observed as being the problems. So we need to make sure that we're doing that, and we want to make sure that, again, we're understanding the cause and effect relationship. And then follow up, this is the act step of the PDCA effort. It reflects on what further changes should be made. In Toyota, they'll tell you one of the most important parts of their problem-solving capabilities is the reflect stage. You need to step back and reflect on what all you did, what all you accomplished, and that helps them to understand where they missed it, where they needed to go do something a little bit more, maybe what they did in a way that shouldn't have gone that direction, or what they really did well, and how to do it. We don't do a good job of celebrating successes for any period of time in U.S. companies. We move on to the next problem, right? We're engineers. We want to solve the next problem and the next problem. So, but at some point you need to step back and take a little bit of time to reflect and celebrate on what the successes have been, because that's how you create a learning environment and create that culture of continuous improvement that you're really trying to achieve. So the other thing in the follow-up section, or the act section, would be who else needs to know about the findings of this improvement? How do we need to share this across the corporation? And Toyota really is a learning organization, and they're serious about how do we share these successes throughout the organization so that we don't have to go fix the same problem in 6 different places. Okay? Toyota calls this, and I'm not even going to attempt that word, but what it translates as lateral deployment of the findings to related groups. So they're really serious about taking this information, what they've learned, and spreading it throughout the organization.
Chrysler called it read across.
Read across, that's right. Yeah. Yes.
I'm not sure, but in the US, do you have competitions for QC story where few employees are selected and then they share their QC stories? Do you have such events?
Well, it depends on the company.
No, like the American Society of Quality or something.
Oh yeah, where they highlight specific problems and solutions they came up with.
Or they have competitions
Yeah,
where
yeah.
Everybody comes from every industry and presents.
Yeah. There are
learn from each other.
right. There are examples of that where you host a. I'll tell you one thing that DMDI did just a couple of months ago was a hackathon. We had a bunch of production data. We came up and figured out ways to analyze that data to come up with potential solutions for problems within the production process. And we had different teams doing that, and from all different companies. They would do, yeah, they have several of those. So these are some examples of some A3s that I've done or I've been involved with. This one actually has to do with a coil tube cell, and it was a Kaizen event. You see, so we're saying here's what the title is. So if somebody comes up and says, "What are you working on?" We're working on the coil tube cell. All right. That's where the problem is. The background was based on future state value stream map in whatever date that was. The Kaizen event was selected to address objectives of changing the layout, developing a cell for cut, in finish, cleaning, cold form, braze, cross-trained members. Is there anybody that doesn't understand what we were trying to accomplish there? It's fairly straightforward, right? One quick sentence. But when we talk about the current situation, here's what we did. We showed, here's the layout. This is the path that a coil tube had to go through the plant. So you can see it was making a lot of loops. It was traveling all the way from one end of the plant to the other end of the plant. So we had the analysis of the current situation, what the problems were. We had a goal of creating a manufacturing cell with one-piece flow. And look, here's our new situation, and there's the path that it goes. So we rearranged the equipment. We put it into, co-located it into a cell, and that just validates what everything Dr. Black was talking about cell manufacturing for the last couple of days. So here's the results. We had metrics on here. Here's what it was before. It took 210 minutes. Now it takes 61 minutes. It traveled 650 feet. Now it's 140 feet. Lead time was 4 to 5 days. Now it's an hour. Okay, made somewhat of an improvement with it. But and here's what our follow-up plan was. These are the different things we had to go do. And exactly what Tom was talking about, the things that were left that we said, these would have been good things to do in this project, but they're for the next project. And here's where your next ideas are coming from. This one had to do with a payroll value stream map. Not everything is production. You can use these on administrative processes also. But because we didn't have a lot of ways of doing layout, this had to do more with what was in forms and stuff. There's a lot more words on this one, right? But what we were able to do is show the flow. So we could explain the flow pretty quickly on what we were trying to achieve. here's what the current state was and the different issues that we had with it. These are some of the recommendations that the team came up with, and these bursts over here show what the Kaizen events need to be to go and solve the problems that we had addressed back here in the current state. And then here's the follow-up plan. This is who all was going to go do it, and different solutions that were going to be implemented and when they were going to be implemented. Here's a project example on eliminating waste at Morton Salt Silver Springs facility. We had the background here. Here's what the current situation was. And here we used sort of a animated type of layout. Look, it's not the real layout of the facility, so it's a kind of a cross between the layout and a flow chart. Okay? The 5 whys was the analysis that we used. So these were the problems we were trying to address. Here's the 5 whys. These are the parts of the process that was. This was what the recommended solution was. Here's the plan we had to go about it. And because this was a little more deeper and Morton wanted some kind of report on it, they actually produced a couple of reports that you could go and look at the details of everything on it. But it was able to show pretty quickly what the problem was and how we're going to solve it. Now this is an example of one that you can actually didn't use all 7 of the areas, right? This one's one on a 5S. You can see we use a lot of pictures on it, so you can use pictures to explain what you're talking about. But it's easy to show. Here we scored an 8. Here we scored a 79. Did we make improvement? Yeah.